All right, today we're going to dive into a really powerful way to make your software testing smarter, not harder. We're going to look at a tool that can literally think of test cases you haven't and find those nasty bugs before they ever reach your users. So let me just start by asking you a question. And be honest. Think about the last bit of code you wrote and tested. Are you 100% certain you caught every single edge case? The weird inputs, zeros, the empty strings. It's that thought that kind of keeps a lot of us developers up at night. And yeah, that nagging feeling, it leads us straight into what I call the test data trap. This is the problem we all run into when we're sitting there manually trying to pick the right inputs for our tests. I mean, we've all been there, right? You write a great function, and then comes the fun part, writing the tests. You pick a few good examples, maybe a bad one to be thorough, but man, is it tedious. And the thing is, our brains are just wired to think about the happy path. We test for the inputs we expect to work. We almost always forget those tricky little edge cases, and that leaves that little voice in the back of your head going, I wonder what I missed. But what if you could flip the script? What if, instead of you trying to outsmart your own code, you had a tool that could automatically generate hundreds, even thousands of clever, tricky, and just downright devious test cases for you? Well, this brings us to a really fundamental shift in thinking. It's called property-based testing. And the whole idea here is to stop testing individual examples and instead start describing the general rules or properties that your code should always follow, no matter what. And this comparison just lays it out perfectly. With traditional testing, we might assert that 2 plus 2 equals 4. That's one specific example. But with property-based testing, we state a universal truth. We say, for any integer x you can possibly imagine, adding 0 to it must result in x. See the difference? We're not checking one little example. We're describing a rule for an entire universe of inputs. So here's the key idea. With property-based testing, your job is just to define the rules. The testing tool's job is to act like this relentless opponent, just generating tons and tons of data to find that one single example where your rule breaks. You might have heard this called fuzz testing, where you just bombard the system with all sorts of weird stuff to see what falls over. So how do we actually do this? Well, for those of us in the Python world, the absolute go-to tool for this is a brilliant library called Hypothesis. And the best part is, it plugs right into frameworks we already know and love, like PyTest and UnitTest. Okay, that's enough theory. It's way more interesting to see how this actually works. So let's take a look at a really simple function and see if we can find some bugs in a little program that calculates an integer's square root. So here are the rules for our function, int square root. It's supposed to take an integer from 1 to 10 and then give us back its square root. Super important, for any number outside that range, it's gotta throw an error. Seems pretty simple to test by hand, right? So instead of writing a test for the number 1, and then another for 11, and maybe one for -5, we just write one single property-based test. We basically tell Hypothesis, hey, generate a bunch of integers for me. My function should either work for the numbers between 1 and 10, or it should raise an error for everything else. And boom, just like that, we run the test, and Hypothesis immediately gets to work. It doesn't just try random numbers like 5 or 7, no, it's smarter than that. It instantly zeroes in on the boundaries. It tries 0, it tries -1, it tries 11, the exact kinds of inputs a developer might totally forget to test, and it immediately finds flaws in our logic. Okay, finding a simple off-by-1 error is pretty cool. But where Hypothesis really shines, where it'll blow your mind, is in finding these subtle, surprising bugs in more complicated systems. So let's check out a real-world inventory example to see this thing in action. Let's picture a simple inventory system. This example is actually borrowed from that classic programming book, The Pragmatic Programmer. So you've got a warehouse that holds your stock, and you can create an order to take items out of that stock. Simple enough? Now, here's the crucial business rule. You should never be able to create an order for more items than are actually available in the warehouse, right? The system has to prevent that. But does it? And how would you even test for that reliably? And this, right here, is where the magic happens. We write a property-based test that says, generate any warehouse and any order you can think of. The one property that must always be true is that if an order gets filled, the warehouse inventory must have been big enough. We run it, and bam, Hypothesis instantly finds a case where you can, in fact, create an order that sends your inventory into a negative balance. That's a critical business logic flaw, found completely automatically. And this just hits the nail on the head. The most valuable tests are never the ones that just confirm what you already know. They're the ones that surprise you, the ones that uncover a flaw you never even thought to look for. Finding these bugs is fantastic, but the story doesn't end there. The real goal is to use these discoveries to build code that's more robust and more resilient for the long run. See, once Hypothesis finds a bug, you have this golden opportunity. You can take that specific failing example it found and you can turn it into a permanent shield, making sure that that exact bug can never ever creep back into your code. So here's how you do it. First, you just let Hypothesis loose on your code. When it finds a failure, it tells you the exact minimal input that caused the crash. You then take that input, like, say, an order for 10 items from a warehouse that only has 9, and you create a brand new regular old unit test with it. And that test now becomes a permanent part of your test suite. This new test has a special name. It's called a regression test. Its only job in life is to make sure that this specific bug you just fixed stays fixed. If anyone on your team makes a change a year from now that accidentally reintroduces this exact flaw, that test will immediately fail, and it will protect your application. So you see, the really crucial point here is that Hypothesis is way more than just a bug-finding tool. It's a system for methodically building a comprehensive safety net for your code. It finds the holes, and then you use its findings to patch them up forever. And ultimately, it all leads back to this fundamental shift in how we think about testing. Instead of just confirming our own assumptions, we can use tools that are actively trying to prove us wrong. And that proactive, almost adversarial approach, that's how truly robust software gets built. So I'll just leave you with this thought. Right now, in the code that you're working on, I can almost guarantee there are surprising edge cases and hidden assumptions just waiting to be discovered. The only real question is, are you going to find them, or are your users?